Honorable Chair, Co-Chair, and dear audience, welcome to my presentation. This is Dr. Mohammad Aminul Islam from Aminullah University of Science and Technology. In the beginning, I would like to thank the organizer for giving me the opportunity to present my research here. In this presentation, I would like to talk about recent spectroscopic innovations for predicting adsorption mechanism. Now, I would like to talk a brief background of my project. Well, recently, numerous materials have been used as adsorbents for environmental remediation. The characterization of these materials is of particular interest and importance from both fundamental and practical viewpoints. Characterization is also important to identify surface morphology and phenomena at the solid-water interface during adsorption. And spectroscopic studies are important tools that enable us to predict adsorption mechanisms at molecular level. Now, in order to understand the topic, let us consider adsorption. Well, adsorption is a complex surface phenomenon, and it is the accumulation of solute from solution onto a solid surface. However, the adsorption process is usually considered as an equilibrium between adsorbate and the surface to form a complex via adsorption or precipitation. Here is surface, here is adsorbate and form a complex. Then adsorption mechanism. Well, adsorption mechanism is nothing but the binding of pollutants to the surface by various means. That is how pollutants bind to the surface during adsorption. Usually, adsorption mechanism is explained in terms of outer sphere and inner sphere complexation. In case of outer sphere complexation, there must involve a water molecule between adsorbate and surface. On the other hand, in case of inner sphere complexation, there must be a direct chemical bond between adsorbate and surface, and there is no involvement of water molecules. Well, recently numerous spectroscopic studies have been employed to understand the mechanism of adsorption, and these include X-ray diffractometer, scanning electron microscope, transmittance electron microscope, ATR, FTIR, C13 NMR, phosphorus 31 mass NMR, XPS, EXS, ZES, and XES, and zeta potential. So, now how to identify the mechanism? Well, usually the spectrum of pristine adsorbent or surface is taken, and the spectrum of adsorbate or pollutant loaded adsorbent or surface is taken at the experimental conditions, and these two spectra are compared. If bands are shifted due to adsorption, then it is considered chemisorption onto the surface. Now let us consider some practical examples for adsorption of cobalt onto barnacite, pyrolusite, hosmenite, and manganite. In case of barnacite A and manganite D, the point of zero search have been shifted to to some extent, which indicates the formation of inner sphere complexation. And other two cases, there is no shift of point of zero search, which means cobalt adsorbed onto these two surfaces by outer sphere complexation. Then comes FTIR analysis, and here is the spectrum for Chi2 and arsenic loaded Chi2. From this spectra, it is clearly seen that after arsenic adsorption, the spectra is slightly shifted, which may be responsible for the formation of inner sphere complexation. Then comes XPS analysis. So here a typical example of XPS spectra for cobalt adsorption onto barnacite at pH 3,6, 8.5 and control cobalt hydroxide is reported. So if we clearly see the spectra, we see that after cobalt adsorption, the spectra has been shifted at different pH values, which indicates that there might be the formation of inner sphere complexation. Then phosphorus single mass NMR spectra. Here I have shown 31 phosphorus single pulse mass NMR spectra of 0.095 molar IP6 adsorbed onto gibbsite at different pH and aluminium IP6 precipitate at pH 6. So from this spectra we see that this spectra with this spectra, this three spectra has been shifted to greater extent, which are responsible for the formation of inner sphere complexation onto the surface. So from this study, the summary of the adsorbent property is usually done by textural property by BUET isotherm measurement, morphology by SEM-TEM, and surface chemistry by drift XPS-FTIR, hydrophobicity by, and adsorption property as I said before, and other properties has been measured. So the key findings of these studies include a wide range of modern spectroscopic methods has been employed to study the mechanism of adsorption. In some cases, macroscopic data have been combined with spectroscopic or a surface complexation model to predict the underlying update mechanism. Adsorption mechanism primarily involves physisorption, ion exchange, electrostatic attraction, hydrogen bonding, and a combination of outer and inner sphere complexation and surface precipitation, usually at higher pH. However, more innovative research is needed to get maximum benefit from spectroscopy in various applications. So these are the reference from where most of the informations have been collected. And this is my YouTube channel, and my research activities has been found here. And thank you all.